So this is our solution for problem number 6 of the second partial exam. In this problem we had to find the lowest number in a matrix. Basically we just had to make the function that would do this. So we had to program the main to fill out a randomly filled matrix. Okay, so basically we create a matrix here. Well, we get the pointer to the matrix here. The matrix in this example is of the size 50 times 50, using a number, of course, here it's 8. Okay, so the idea here was to split the total amount of pieces of blocks of the matrix into the number of cores we have, and we call here the function waiting for the result. Okay, so we send as a parameter the dimension for both rows and columns and the address to the first block of the matrix and the number of cores, of course. Okay, in the main we fill out the matrix here with a random number, which maximum would be 100 and minimum would be 5, just to make sure everything was working okay. Okay, so in the function that we create the threads, here we create a pointer to an array that will store the minimum values found in each thread. Here we're going to create the array of structs that would be the data that will be sent to each one of the threads, and an array here of handlers for each one of the threads. Okay, first of all we have to explain a little bit about the structure that's going to be used. We have basically two integer pointers, one for the block of the array that will store the minimum value found in each thread, the pointer to the matrix itself, and a long that will contain the amount of blocks to check in the matrix. Okay, so in the function that creates the threads, we calculate the total size of the matrix, just multiplying the rows times the columns, and we split that in the number of threads we have in the system, and we store also the remainder of this previous calculation to include the blocks that might not get into the threads if we're going to split equivalently. Okay, so next we have a for here that makes each one of the threads. We just fill out data that will be sent in the structure. Okay, here we have the pointer to the lowest matrix, the lowest array that's going to be storing the lowest number of found in each thread. Here we just give the pointer to the matrix, and by the way we're using the matrix as a regular array, and here we're just increasing the amount of blocks per thread that we just calculated over here. Okay, so here we create the thread, and we create the last thread outside the for loop, because we have to include in the number of blocks to check, we include the remainder of the previously calculated value here. Yeah, the remainder of the blocks that would not be evenly distributed among the threads. Once we finish our thread, all of our 8 threads according to our number of cores, we just run a for loop just to compare each one of the lowest values found in each thread, And after that we just free the dynamically allocated array of lower values, the array of structures to the thread, and the handlers of each thread, and we just return the lowest value. In our routine for the thread, we just cast the pointer into a data structure that we define over here, and with this one we take out the pointer to the block where we will store the lowest number found in our thread. We also take out the starting point of the matrix that we're using as an array, and we take out the amount of blocks that we will be checking in this thread. So we initialize the lowest value as the first data in the matrix, and we just go through every one of the blocks until we reach the maximum number this thread will be checking. And if each one of the block data found in the matrix is lower than the previous one stored, we just store that one in the array. And after that we just go back to the wait for multiple objects, and we just go through checking each one of the lowest values found in each one of the threads. An example of this is over here. We ran the program with 50 times 50 with random values between 5 and 100. So basically we have here all the matrix printed out in the command line, and the minimum value was 5 because each one of the threads found that probably you have at least 1 5 in each one of the blocks, and if not, you would still get the 5 because each one of the threads would have, I mean, the 5 would be the lowest value possible in the matrix. That's it.